Hello everyone, hope you all are doing well. So today we are going to do the next topic of our geography series. जो हमारी geography series चल रही है उसका next topic को आज हम लोग करने वाले हैं. And the topic we are going to discuss today is atmosphere. आज हम लोग एटमॉस्फेयर के बारे में डिस्कस करने वाले हैं. बट बिफोर स्टार्टिंग आई मस्ट लेट यू नो वन थिंग दैट प्लीज डू मेक नोट्स. जो भी मैं बता रहा हूँ उसका नोट्स बनाते रहिए बिकॉज द नोट्स विल बी वेरी हेल्पफुल इन योर रिविजन. Because remembering all the facts and all the concepts by just seeing the video will be not easy. By making notes and revising those notes again and again will help you to remember the things for longer periods. So please do make notes. So let's start the video now. So what is atmosphere? So atmosphere is the blanket of gases in reaching the encircling the earth. Blanket of gases encircling the earth. Circling the earth. And when we see these gases, so one thing that is always asked, some many times have been asked in the examination, that is the arrangement of gases from increasing to decreasing trend or decreasing to increasing trend. So that has been asked, so we will see it. So highest amount of gas that is found in atmosphere is nitrogen. Around 78% of atmosphere is composed of nitrogen only. Then we have oxygen, which is around 21%, and rest all gases comprise just 1% of atmosphere. And this is the trend that is from increasing to decreasing, highest to lowest. Okay, then after oxygen you will see argon, then after argon there is CO2, after CO2 we have neon, and after neon you will have helium. So you will see that, and these four are important because many times students confuse between argon and carbon dioxide when asked in the examinations. So although you should know all the six, but you should be knowing this differential, that argon is in higher amounts in our atmosphere as compared to carbon dioxide. So highest amount is of nitrogen, then oxygen, then argon, then carbon dioxide, then neon, then helium. So this is about the gases present in the atmosphere. Now we will see about the formation of atmosphere. Formation. So first of all, when Big Bang happened around on Earth around 5 million years ago. Okay, here the Earth was 5 million years ago. Here the Earth was molten. The Earth was in molten condition. Then it started to cool down. Sorry, here the temperature of Earth was 5 million degrees Celsius. Okay, 5 million degrees Celsius. That is why the Earth was in molten state. Not years, it is 5 million degrees Celsius. And then the Earth started to cool down. So during the cool down phase, it was contracting. So when Earth was contracting, the gases were coming out of it. The gases were coming out. Gases. And this process is known as degassing. Degassing. So due to the gases coming out of the contraction of Earth, the primitive atmosphere was formed by degassing. Primitive atmosphere was formed. In the primitive atmosphere, you will see the gases such as H2, CH4, that is methane, NH3, that is ammonia, CO2, that is carbon dioxide. So these were the primary gases in primitive atmosphere. This primitive atmosphere is also known as reducing atmosphere. The atmosphere started to reduce. By this reduction, complex organic matter were developed. Complex organic matter were developed, and due to this organic development of these complex organic matters, plants were developed. And what these plants did, these plants converted CO2 into O2, as you all know that plants can do that, and they also converted NH3 ammonia into N2, that is nitrogen gas. So nitrogen gas in the current atmosphere comes from ammonia, and the oxygen in the current atmosphere comes from carbon dioxide. So that made the formation of current atmosphere containing high amounts of nitrogen and oxygen. So this was the formation of atmosphere. So I hope by seeing this timeline or by seeing this chart, you are able to understand this. Now we will see the structure of atmosphere. So let's see the structure of atmosphere. So this is the surface. Here you will find poles, and here you will find equator. Okay. So up to 12 kilometer, you will find troposphere. This is up to 12 kilometer. Here you will find troposphere, and here you will find tropopause. This layer is tropopause, and tropopause on equator is higher, that is around 12 kilometer, but tropopause on poles is at lower altitude, that is 8 kilometer. It is the tropopause. Tropopause. And then here you will find the just over tropopause, in this region you will find the ozone layer. It is the ozone layer. This layer here is ozone, and ozone is found in which layer? Stratosphere, the lower parts of stratosphere. And stratosphere is up to 50, around 50 kilometers, and at that 50 kilometers you will find stratopause. Find here stratopause around 50 kilometers. Then when you move over stratosphere, you will find mesosphere, and you will find mesopause. This is around 90 kilometers. Mesopause is around 90 kilometers. Over mesosphere, you will find ionosphere, and over ionosphere, you will find thermosphere. This is the port related with the border of ionosphere, and over it, thermosphere. So this is the structure of Earth. But what you should be knowing here, and up to mesosphere, one thing you should know here, up to mesosphere, we have Indosphere. This region is known as Indosphere, and the layers of atmosphere over mesosphere are known as exosphere. That is outer atmosphere, exosphere. And what you will be seeing, what we should know here is that the lapse rate. We will be discussing about the lapse rate. So there are two kinds of lapse rate. First one was normal lapse rate. What we write is NLR. So it is known as positive lapse rate. That is lapse rate. That is when you go when we go in upper altitudes, the temperature will decrease. But just opposite of it, we have reverse lapse rate. That is when you go above in the altitude, the temperature will increase. It is also known as negative lapse rate. So in normal lapse rate is what? With increasing altitude, there will be decrease in temperature, but in reverse lapse rate, it is just opposite. That is, with increasing altitude, there will be increase in temperature also. So that we should understand here. So in troposphere, up to tropopause, you will find normal lapse rate. That the temperature is decreasing as we are going up. But over tropopause, as we cross the tropopause in the ozone layers, you will find that in stratosphere you will see reverse lapse rate. reverse lapse rate. That is, the temperature will start increasing with increase in height. And again, in stratosphere you will find normal lapse rate. Sorry, in mesosphere, stratosphere we will find reverse lapse rate. In troposphere normal, stratosphere reverse, and in mesosphere you will again find normal lapse rate. That is, temperature again is decreasing with height, normal lapse rate. But as we pass the mesopause, we will again find reverse lapse rate. Reverse lapse rate, that is, temperature is increasing with increase in height. So this lapse rate has been asked various times in examinations, in which layers we will find a normal lapse rate, and in which layers you will find reverse lapse rate. So please do keep in mind, in normal lapse rate is found in troposphere and mesosphere, and reverse lapse rate is found in stratosphere and the exosphere of the earth, of the atmosphere of the earth. So this was the structure of atmosphere. Now we will see each and every layer in detail. So first of all we will discuss about troposphere. So troposphere is zone of turbulence. Zone of turbulence. All because all weather conditions of earth occur here only. Almost all weather conditions of earth occurs here only. You will also find that 99% of earth moisture is here only, in troposphere only. 99% of earth's moisture is here. Earth's moisture is here, and here you will find normal lapse rate. So this was about troposphere. Now we will see stratosphere. Stratosphere. So here we will find gases which forms layers of strata. That is why its name is stratosphere. At the lowermost strata you will find ozone. Lowermost, as you can see the diagram also, the ozone is at lowermost strata of stratosphere. Lowermost strata you will find ozone, which blocks UV rays. And here you should know that as it blocks UV rays, the ozone found in stratosphere is known as good ozone, but the ozone found in troposphere acts as pollutant, and hence it is known as bad ozone. So please keep it in mind. The ozone in stratosphere is known as good ozone because of its role in blocking UV rays, but the ozone found in troposphere acts as pollutant and it is known as bad ozone. Okay, so please keep it in mind. So here you will find that as the bottom strata has ozone, or lowermost strata has ozone, so this bottom strata gets heated up because of ozone, because it is blocking UV rays. So due to that UV rays, the energy of UV rays is hitting the bottom strata, heated up, and transfer heat to above strata, and transfer heat to above strata, and that is why we see reverse lapse rate in stratosphere. What happens as the ozone is blocking the UV rays here, the energy of UV rays is also blocked, which heats up the lowermost layer of stratosphere, and this heat is transferred to upper portions. This heat is transferred to upper portions, and that is why you will see reverse lapse rate in stratosphere. As you go up, the heat or temperature is also increasing. So this was about stratosphere. Now we will discuss about mesosphere. Mesosphere. So here again we will see normal lapse rate. Okay, as away from surface of Earth. As away from surface of Earth. Okay. It is the coldest part of Earth's atmosphere. It is important you should know, because after mesosphere again reverse lapse rate is seen. So it is the coldest part of Earth's atmosphere. And meteors burn here only. Okay, meteors burn here. Meteors burn here, and they create, and it leads to creation of meteor shower. So whenever a question is asked in which layer meteor shower is observed, so it is mesosphere. Now after mesosphere, we will see the important points of exosphere, that is outer atmosphere. So the bottom strata of exosphere is ionosphere. Its bottom strata is ionosphere, and we all know that this ionosphere is very important for any kind of signal. The signal that is going from the earth, the signals that we are receiving on earth is important because of the ions present in this ionosphere. Here in exosphere we will see that gases contact, and this forms the high energy insulation because we see that here we have charged atoms. Atoms are charged, which forms ions. Ions, that is, these ions can be positive ions or negative ions. Negative ions or positive ions. So here you will find reverse lapse rate. Reverse lapse rate because with increase in altitude, the energy of gases increase. The energy of gases increase, but this energy doesn't manifest in form of heat because gases diffuse. Doesn't manifest in form of heat as gases diffuse. This is why as we go in increasing height in exosphere, the temperature also increases, showing the reverse lapse rate. So this was about exosphere. Now we will discuss one more important layer, which is magnetosphere. Okay, this is important. Okay, so this magnetosphere is found in outer core. So what happens? This outer core, actually this magnetosphere doesn't is occurring in outer core. It is due to the regions of outer core because our outer core acts as bar magnet. Acts as bar magnet. As bar magnet. This is an acts as bar magnet, and similar to bar magnet, magnetic lines of forces encircles Earth, forming magnetosphere. Magnetic lines of forces encircles Earth, forming magnetosphere. So see what happens. The diagram I'm explaining. This is our Earth. Okay, this is our outer core. Okay. And this outer core is behaving like a bar magnet, that is related with negative and it is positive. It is the core, it is outer core of the Earth, and this is our Earth. And this outer core is behaving as bar magnet. That is why it is creating a lines around it as the bar magnets create, forming the magnetosphere like this. These are the lines as created by bar magnets, and this is how magnetosphere formed. And this area is known as magnetosphere. fair. Okay, we will also discuss some important points here. It extends from surface to 6300 kilometers. Extends from surface to 63,000, sorry, not 100, 63,000 kilometers. It is a very vast area. It covers a very vast area. It traps, it helps trap gamma rays and X rays, gamma rays and X rays from insolation, that is incoming solar radiation, insolation that is incoming solar radiation, and also protects Earth from solar storm, and also protects Earth solar storm, from solar storm and coronal mass ejections. Coronal mass ejections. So which layer protects Earth from solar storm and coronal mass ejections? It is coronal mass ejections. It is magnetosphere. So I hope you understand it. Now we will see some of the important things in magnetosphere. In magnetosphere only, there is a charge particle belt. Okay, that is known as Van Allen belt. In magnetosphere, you will find a belt of charged particles. This like this. In this, you will find charged particles. Charged particles, and this belt is known as Van Allen belt. These charged particles form Van Allen belt. It is important to remember the name. And this is only, this layer is known as magnetosphere. And one more thing which is important, that is in magnetosphere only, due to these charged particles, you will find forming of auroras. So at the upper parts, that is towards the Arctic regions, you will find aurora borealis, and in the Antarctic regions, that is southern part of the earth, you will find aurora australis. Aurora australis. From boreal conditions here borealis, and from Australia here australis. So remember the names. So this was about magnetosphere. So this was all the important points about atmosphere which are can be potentially asked in the exams have been covered. So I hope you like the videos. So if you like the videos, please press the like button. Please do share, and please do subscribe. It takes a lot of hard work to make such videos for you on रेगुलर बेसिस पे ऐसे वीडियोस को बनाने के लिए आप सबको के लिए काफी हार्ड वर्क लगता है. एंड इफ यू लाइक, इफ यू शेयर, इफ यू सब्सक्राइब, इट मोटिवेट्स अस टू मेक more such videos for you regularly. So that is all for today. Have a nice day. Thank you.